Hey there, my pre-calc people. Today we're looking at 2.12a logarithmic function manipulation. We're looking at different properties of logs that help us combine them into one or separate them into multiple. What we're actually doing is we're going through and we're doing our exponent rules. You guys remember when we talked about those a while ago? So like if I'm multiplying in my log, just like if I'm multiplying my bases, I add my exponents. I add my logs. Same is true with natural log. If I divide two things, I subtract my exponents. So if I'm dividing in the log symbol in the parentheses, I can subtract my two logs. And then for my power principle, if I take it to a power, a power to a power, I multiply. So I multiply my logs. Okay, this is going to make more sense when we see some examples. But just remember, these rules are actually the same as our exponent rules because they are exponent rules. Okay? You want proof? I don't do any proofs, but I don't know. Hang around with some math majors. Some nerds. Okay, I digress. Let's do some examples. Expand using the properties of logs. So this is 8 times x times y to the 4th, right? So anywhere where I see a multiplication, I can expand out and use addition. Now I have to keep my base the same. So this is log base 10. So I'm going to keep this one log base 10 to log of 8 plus log of x plus log of y to the 4th. So I'm just keeping the same log. Anywhere I'm multiplying, I add and separate out. Now, it's almost simplified. Now here I have an exponent. And why? The whole reason we have these logs is to get rid of exponents, actually. I can take that 4 and move it out in front based on our power rule. So my final answer on this would be log of 8 plus log of x plus 4 log of y. Loggy. Okay? Okay. Let's do it with b. So on b, do a natural log. All the same rules apply because natural log is just log, but base, e. So first thing I'm going to do is I'm going to rewrite this. Square roots, there's no rules for square roots. They're lawless. I'm going to change that x squared plus 5 to the 1/2 over x, right? Yes, remember that. Now I see I have a division, right? Where here I had multiplication, so I added. With division, I take my two pieces, my denominator and my numerator, my top and the bottom, and I subtract them. Keep that natural log there. All right. Divide, we subtract. Multiply, we divide. So now I take this 1/2, and whenever I have a power, I can move it in front. So I do 1/2 ln of x squared plus 5 minus ln of x. I'm done. We're done. We can't simplify this one right here because I'll highlight it. We can't simplify this one because it's not, adding is not one of our rules, right? We can only do it for multiplying, dividing, or a power. That one I can't simplify anymore. I can't break into pieces, okay? All right, that's good that we can do that. Let's see if we can go in reverse. If our transmission's working, we can. All right. Or actually, if it's not, you can't get out of reverse. All right. So condense these logarithms into one piece. So I have two pieces. I want to make them into one. Well, I'm subtracting. Subtracting means I can combine what I'm taking the log of. Whenever I subtract, I can divide. Oh, before I did that, can I get rid of this 2 in front? Yeah. Right? There's a 2 in front. That means I can take this to the power of 2. So that's natural log of x, y to the 2. The tutu. Oh, that's x to the 5th up here. Okay? If you want to be really good, it'd be natural log of x to the 5th over x squared, y squared. And what's 5 divided by 2? X to the 5th divided by x squared, x to the 3rd over y squared. All right. Holy smogolies, look at number 3. All right. First thing I'm going to do is move my powers to the back this time, just for fun. You know what I'm saying? So this is going to be natural log of x to the 3rd, y, that whole thing to the 3rd, plus 2 natural log yz squared to the square. Oop, that 2 goes away. I moved it. You goofy gossip. Alright. So now if I'm adding, I'm multiplying, right? So that's natural log of x to the 3rd, y, all to the 3rd, times yz squared to the 2nd. Let's simplify this beast so they don't come get us. So x to the 3rd is x to the 9th. Y to the 3rd is y to the 3rd. Y squared is y squared. Z squared to the 2nd is z to the 4th. Y to the 3rd times y squared, we add our exponents. So we do x9, y5, z4. Good old algebra coming back to us. All right, and the next one I actually already taught you way ahead of time. I'm gonna reorganize these. You guys are my guinea pigs. Change of base formula. We've talked about it. We've done it. We've loved it. It's been our favorite thing we've ever done. I don't know if that's true. I can change any log to whatever base I want. You don't believe me? Well, too bad. You really should just please believe me. So if I have some log that's a number I don't want, I can change it to log base 8 by dividing my top by my bottom. Again, we did this in class. I can change it to base 10 by doing log over log, top over bottom. E, natural log over natural log. Okay? So let's change these. Let's change them all by changing the base. Does it matter which formula I use? No, I would stick to 10 or natural log because they're in your calculator. Okay? So let's do A. So I do natural log of 13 over natural log of 3. Top over bottom. Get 2.335. Could I have used log base 10? Of course. Like, watch this. You can prove it. You can do log 13 divided by log of 3 and see what you get. I bet just the same answer. Alright. So then for B, I would do natural log of 10 divided by natural log of 6. 1.285. And for C, I would do natural log of 2 over natural log of 0.5 or a half. And get -1. All right, which makes sense because 1/2 to the -1 power is 2. Well, that's all this video is going to be. I probably could just do 4, but I won't yet. All right, I hope you enjoyed. Hope you learned something. Have a good day.